Welcome guys to a new video. It's a question about a quadratic function. Let's have a look. Past paper question, exercise 7. We have f of x equals to mx squared minus 2mx. X and m are both real numbers. The line y equals to mx minus 9 meets the graph of f at exactly 1 point. Show that m equals to 4. Okay, well, let's have a look. Let's try it out. We know that if they have 1 point of intersection, it means that these equations must be equal. This one, the equation of f of x, and the equation of y. So we're gonna do, for question A, mx squared minus 2mx equals to mx minus 9. Then we have the following. We're going to transfer some terms. Let's bring the right side onto the left side and make this equal to 0. Mx squared minus 2mx minus mx plus 9 equals to 0. Let's clean it up a little bit. We have mx squared minus 2 minus 1, that's minus 3mx plus 9 equals to 0. Now let's approach this as a quadratic function. We have a, b, c. This is a as a coefficient, this is our b, this is our c. Let's work with the discriminant, b squared minus 4ac. That's going to be minus 3m to the power 2 minus 4 times a, which is m, times 9. Then keep solving. We have 9m squared minus 36m. Now what do we do with this discriminant? Well, since they only have 1 point of intersection, we are going to consider that the discriminant must be 0. So we are going to say the discriminant must equal 0. So we will have 9m squared minus 36m equals to 0. Get m bracket 9m minus 36 equals to 0, which means either m equals to 0 or 9m minus 36 equals to 0. Then we can solve 9m minus 36 equals to 0, which brings us to 9m equals to 36, m equals to 4. Since in our question we had to show that m equals to 4, yes indeed m is 4, because m cannot be 0. Since m would be 0, we would not have a quadratic function anymore. So the first option of m equals to 0 is not even possible. So therefore indeed m equals to 4, and we have proved it. So that's one question done. For question B, we have the following. The function f can be expressed in the following form: 4 times x minus p, x minus q. Find the value of p and q. Okay, well, we can do the following. For f of x, we can put the substitution for m as 4, and we will have the following function. We will have f of x equals to 4x squared minus 2 times 4 times x, which is 4x squared minus 8x. Now remember that we need to have the following shape: 4 as a constant, x minus p, x minus q. Let's try to factorize. If I'm going to have 4, I will have 4 times bracket x squared minus 2x. Is this good enough? Not yet, because I still have to factorize x squared minus 2x. So we will have 4 times x times, now if I factorize I have x minus 2. So I can answer the question because I will have this one can be written as x minus 0, and this one can be written as x minus 2. And in this case we will have the p and the q as 0 and 2 respectively. So this could be our p, this could be our q, and that concludes our question. So p is 0, q is 2. Hope this makes sense. Let's go to the next one. The function f can be expressed in the following form: find the value of h and the value of k. Now this structure over here and this structure is actually not that far from each other, but we have to do an additional step. We can see we have x minus h to the power 2, so technically we need to have x minus a number to the power 2. If you guys remember the following formula, a minus b to the power 2. That's a squared minus 2ab plus b squared. This property can be applied here. X can write x minus 1 to the power 2 and see how close we are to the following thing. We will have x squared minus 2x plus 1. This is not bad because we're almost there. We actually have this over here, but we have a plus 1. This is not a problem. We will just subtract 1 when we replace it. So in other words, we're gonna do the following. 4 times, I'm gonna put a big bracket, x minus 1 to the power 2. Remember, I had a plus 1 at the end of it. I actually don't want the 1. I only want to have x squared minus 2x. So I will subtract the 1. Okay? I will subtract the 1. And then I can open the brackets and I will have 4 times x minus 1 to the power 2 minus 4. Now this is looking much better because I can go back to my question and provide the answer. Look, it's exactly the shape they wanted. It's 4 times a bracket squared plus k. So the h and the k will be, in this case, 1 and minus 4 respectively. I have the 1, which is my h, and I have plus k, which is a minus 4 over here. So these are going to be our answers. Let's continue with the last part. So in question D, we have to find the values of x where the function or the graph of f is both negative and increasing. Okay, first of all, remember we're still dealing with a quadratic function. And when it comes to the quadratic function, given we don't have access to a graph calculator, we have to make sense of the graph ourselves. I will still sketch the graph, and I will show you how you can sketch a graph without having access to a calculator. It's not really that hard. There's two things you want to keep in mind. You want to keep in mind these two structures, this one and this one. Each structure gives you information. P and Q are called x-intercepts or zeros. This is gonna be helpful. I'll show you how. And in the second structure, when you have such a shape, this h is the x-coordinate of your maximum or minimum point depending on what kind of graph you look at. So I'm gonna put x of critical point. Could be maximum, could be minimum. Now look how this helps you. You know that the original function is 4x squared minus 8x. We did that all the way in the beginning of the question. You can check your notes, you can look back in this video to see what it was. I'll just keep going from here. 4x squared minus 8x. You guys should know that when you have a positive coefficient next to x squared, the parabola looks like this. So that's good to know already. You also know that this function was written as 4 bracket x minus 0, x minus 2. And what did I tell you a minute ago? These are your zeros. Zeros meaning on your x-axis, right? You are going to have the 0 and the 2 like this and like this. So this parabola has to intersect the x-axis at those points. So you are gonna have this thingy. Now the question asks you to find the interval where f of x is negative, you see, and increasing. Now negative means your output values have to be below 0. So on your y-axis you're interested in this range, but you're interested in the increasing part. So you want to go from the minimum point up. What is that? Well, I will show you right now. We go back to the second shape of the function, which was here. Remember what I told you? The number in this bracket is showing you the x-coordinate of the critical point. In our case, it's the x-coordinate of the minimum point or the vertex, okay? So that means the x-coordinate for this green point that I drew in my hypothetical graph in my illustration is 1. So now I can conclude that my x has to be between 1 and 2 in order to have the function increasing and still be negative. Hope this all makes sense. We are done. If you like the video, please drop it a like. If you studied this course, make sure to subscribe. I'll have all kinds of content that's going to be helpful to you. See you in the next one. Bye.